on the sun.
There's our amount.
Before we play the video, there's going to be a video on life and death of a star. A star begins its life as a really big cloud of dust, and through gravity, it begins to condense into a protostar, which is the first stage of the star, and then it goes through its transformation into a yellow dwarf, which is our sun. And then after that, it goes into a red supergiant, and during its final stage, it's a white dwarf, and eventually into a supernova, possibly a black hole. You have the cloud forming into the middle of the sun, which is condensing to a very dense manner. And there you have the first stage of the sun, which is the protostar. And then after that, you have the stage that currently our sun is in. And this takes a really long time, billions and billions of years, to go through a full life cycle of the sun. And then here you have the final stage of the star, the white dwarf. And then after that, it explodes into a supernova, forming a black hole. Our sun is referred to as a yellow dwarf because of its color, yellow, and it's a dwarf because it is comparably very small to other stars.
This is a sun timeline that we did basically discoveries about the sun. And since you can't really say when the sun was discovered, because it's always been there since life was on the earth, we took it at a different angle, saying when the sun was first discovered as a star. And that was in 450 BC by a Greek philosopher Anaxagoras.
Have a cutout of the sun, which we made into clickable parts in each. So we can go through each part of the sun. We can go to the core. And the core takes up only about 2% of the sun's volume, but in relation to that, to its mass, it's really, really dense, and it makes up 50% of the sun's entire mass, although it's only 2% in volume. The sun's core extends from its center to the radiative zone, and then we can go back to the radiative zone, which really takes in the core also is where the fusion reactions become, where the sun gets all its power. Fusion reactions of hydrogen atoms forming into helium take place, and they form gamma rays through photons. And these photons travel through the radiative zone, but it takes them a really long time to get through it. It takes them about 200,000 years for a photon to make it through the radiative zones, which means the light that we see on Earth here from the sun is at least 200,000 years old.
Next, we're going to click on the chromosphere. The chromosphere is a section of the sun that normally cannot be seen, but during a total eclipse is able to be seen. That's how it was discovered. Okay, the photosphere is, let's see, the lowest layer of the atmosphere, and it's a lot of times referred to as the sun's surface. It's where there's a lot of heat and
the convective zone is really the zone that follows the radiative zone is really just molten plasma, and then the way the photons travel through that as well, but they don't take a straight line through. They zigzag through the sun, and they collide with other hydrogen atoms, and it's 66% of the sun. We also have here, in comparison, how big the sun is compared to Earth. So Earth is that little red dot, and then we have our sun. And because the sun is really small, our sun is here compared to a different star. So it's here and then here, which means it shows us really how actually small our sun is and how small we are compared to other stars. And this is a picture representing the forces that go on within the sun, really nuclear fusion, which creates a lot of power, and this is how the sun is able to sustain itself and create its power throughout. The sun makes, in 1 second, as much energy as we and all of humanity have made throughout history. So for 1 second of the sun being lit and doing its thing, it's made as much as energy as we have from the beginning of time.
Okay, for eclipses of the sun, with lunar eclipses, the moon completely covers the sun to make it seem as if they're the same size. But in reality, the sun is 400 times bigger. It's just that the sun is also 400 times as distant. So what you see isn't actually reality, when it comes to size.
If these numbers weren't exact, the moon wouldn't cover up the sun completely. It's a coincidence that the moon is exactly 400 times as distant from the sun as it is 400 times smaller. We did all. The sun.
You done?
Yes.
Any questions for the gentleman?
Michael?
Can you go back to the slide comparing the Earth to the Sun and the Sun to the other star?
Yes.
What kind of star is the VY kind of star?
Well, this is really what, compared to the biggest star out there, but most stars in the universe would be as big as Canis Major, and our star is really it was really an interesting illustration to show how small our sun is compared to other stars, and how small we are compared to it.
I just have to do a correction. What he just said is untrue. Most stars in the universe are like our sun in terms of their size. The size of our sun are smaller. Most of them are not the size of Canis Majoris. Our sun is a very average star. I just didn't want you to let that plant and take it with you, because stars is a big part of this course. Other questions? All right, so I'm going to offer you guys some feedback. The intent of the feedback is for all of us to learn and get better. So today, we would expect presentations to be at one level, but next Friday, whoever's presenting, we would expect to start incorporating the feedback I'm giving you so you can get to be super awesome. Everybody's going to get up here and do a good job, but we're going to get to be professional quality, better than adults you see presenting, okay? Students will email me from college saying, we had a presentation and I destroyed everybody in the class because of what you taught us in the course. So the purpose of the feedback has in no way, shape, or form an intent to embarrass anybody or anything. We are a group of people just learning how to present better. And hats off to these guys going first, right? That's a tough place to be. Okay, so what I'm going to do is start drawing your attention to things to be thinking about when you're presenting. So in the opening, they're standing there waiting for everybody. Standing there waiting for everybody. They've got a slide up there. It says who they are. It's got the topic. It's usually very simple or breathtaking, something like that. So you've got this period of time while everyone's waiting to start. They know what it's about. Okay? Then the first words we say are important. We need to give thought to that. What Enrique said was, well, as you can see, our project is on. So that it's actually something unnecessary to say. So you want to think about that first statement or sentence that you have and that you make to draw people in. Is it meaningful or is it just filler because you're uncomfortable? And as beginning presenters, it's oftentimes filler because we're uncomfortable. So that's something to think about. The video. The video was very, very confusing. I do not think it was a good choice because it showed the life cycle and evolution of multiple different types of stars, not just our sun. It also depicted, and you said, that our sun is going to end up with a supernova. That's not true. So we want to be very, very careful. I was very confused at the beginning because Ivan was actually doing something very good. He wasn't using other people's narration. He was going to narrate over it. So that's actually an advanced technique. He's going to tell us, he's going to use someone else's video, and then he's going to tell us what he wants us to hear the way we want it, which is great. We just have to choose it well, and what we say as well. So for about the first third of the video, I thought you were trying to explain what we were seeing in real time, which was not at all what was happening. What you were saying was not at all connected to the video.
They're supposed to be.
Well, like
Didn't work out.
you know, the columns of creation were up and you were talking about white dwarfs, right? So the pillars of creation, excuse me. So there wasn't this connection, so I had a very difficult time figuring that out. But then there was a point where you jumped in and you kind of did, because the video looped, if you notice that, like 3 times, and it was played sped up. All that footage is from the series, The Universe, and it was sped up. But the confusing point was that there were multiple types of stars, and the one that was about a yellow giant's life cycle ended in a supernova, which is not what's going to happen to our sun. Our sun is not large enough for that to happen. It is going to form a white dwarf, but white dwarfs don't go supernova. They just slowly cool down and fade away. If they're a little bit larger, they can go supernova, but our sun is not one of those. So in any case, some advanced techniques in the video of you doing that voiceover was a really good approach. We just need to choose and map it together better. The timeline approach, really ingenious, I thought, because duh, everyone has seen the sun all that time, so you're going to take a different approach with the timeline. So I like that a lot, but then I wondered why you only spoke about the first event on the timeline. So I wondered why that happened. And maybe you just forgot and came back to it, or didn't come back to it because you forgot because you were nervous in presenting. All of those things can happen. Something all of you may be unaware of is that the industry standard for presentations is if you expect your people to read it, it needs to be at least size 16 font. Anything else is not considered readable in an audience. Okay? So just be aware of that. So now we go to this other excellent advanced technique in using the slides, where I think all of you will should get to very quickly. So they picked this one diagram of the sun, and they then created all these hyperlinks to other pages and kept going back to it. Brilliant, brilliant, sophisticated strategy. But what all presenters who enter 11th grade tend not to do, and it's exactly what happened in the Regents class this morning, it happened to every group that presented, you need to take the time to explain and point out all the details on the diagram. So can you go to that page for me? So this is great. This is awesome. Okay, so what you want to do is say, here is point